In this video, we're going to learn how to do scientific notation. Scientific notation is a way of writing any number in a smaller way. It's usually used to make really large numbers appear smaller, so we don't have to write out all the zeros, or to make a really small number look smaller, so we don't have to write out all the zeros. So this number here, this is 10 million. And any number that is one or greater is going to have a positive exponent sign. And any number that's lower than one is going to have a negative exponent sign. Let's see what this would look like. So we have the number 10 million. So what we always do, we start at the last number. So we're right in front of the last number. So zero is the last number. So I'm going to be right in front of it. Okay. So I'm going to put a decimal right here. And then I'm going to go to the left until I reach the first whole number. So let's see. One, two, three, four, five, six, seven. So I'm at the first whole number. I moved 7 times. So we're going to write this as 1 times 10 to the seventh power. 10 to the seventh power is 1 with 7 zeros. So that's 1 and then 7 zeros, 2, 3, 4, 5, 6, 7. And if I put in the commas, 10 to the seventh power is equal to, looks like I missed a number. Hold on a second. 10 seventh power. There we go. So we're going to now put in the commas, comma, comma. So 10 to the seventh power is 10 million. So that's how we solve this to write it in scientific notation. Let's look at the next one. Okay, so this is 10 million, 10 billion, 10 trillion. So we want to write 10 trillion in scientific notation. So we're going to start at the last whole number. We're going to write the decimal, and then we're going to go to the right until we reach the first whole number. So 1, 2, 3. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's double check we did that right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we move 13 times. So that's going to be 1 times 10 to the 13. That's our answer. So instead of having to write 1 and all these zeros, we can just write 1 times 10 to the 13. And the reason this is used is because there is no largest number in the world. Numbers go on forever. So when we're talking about distances from the Earth, or we're talking about the solar system, scientists will write numbers using scientific notation to express distances that are very, very far. Now, we also have the same thing in reverse when we have items that are very, very small. So this is smaller than 1, much, much smaller than 1. So we start at the decimal and then we move to the right until we reach the first whole number. So let's do this. So we have 1, 2, 3, 4, 5. So I move the decimal 5 spaces. So the exponent is going to be negative because this number is smaller than 1. So answer is going to be 9.58 times 10 to the negative 5. Let's look at this one. Okay, so we have a lot of zeros. So we're going to start at the decimal, and then we're going to move until we are behind the first whole, or in front, depending on how you're looking at it, the first whole number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we move 12 times. So the exponent is going to be 10 to the negative 12. And then we write the remaining numbers. So 9.5 times 10 to the negative 12. Let's do some more examples with smaller numbers. Okay, so like I said before, when we have a whole number that's 1 or greater, the exponent is going to be positive. And if it's a number that's smaller than 1, the exponent is going to be negative. So let's look at this first one. So let's first start with the numbers that are 1 and greater. So I have 55,820. So I'm going to start just outside of the last whole number, and then I'm going to go to the left. So 1, 2, 3, 4. That's going to be 5.582. And I moved, let's see, I moved 1, 2, 3, 4. I moved 4 times 10 to the fourth. And 10 to the fourth is equal to 10,000. That's 1 and then 4 zeros. 1, 2, 3, 4. That's 10,000. So 5.582 times 10,000 is 55,820. Now you might be saying, why didn't I add the zero? It's customary not to add the zeros. After you have, if there's only one zero left, you just leave that zero out. But if there were more whole numbers, then you would include those numbers. So let's say this number went out to here, then you would include the 2 and the 5. But once it's all zeros, you can stop adding the zeros to your final answer. All right, let's look at number 7, 856. So we are going to move to the left until we get to the first whole number. So 1, 2. So we move 2, and the remaining number is 8.56 times 10 to the second power. So we have 1.216. Now, the decimal is already behind the first whole number, so we don't have to move any decimal. So we're going to write 1.216, and since we didn't move the decimal, it's just going to be 10 to the 0. And 10 to the 0 is equal to 1. That's something you want to remember. 10 to the 0 power is equal to 1. Let's look at number 13. So we're going to start by the last whole number. So 1, 2, 3. Let's go back. I lost my count. 1, 2, 3, 4. So we move the decimal 4 times, and the remaining number is 7.5919 times 10 to the fourth. Okay, let's now do some numbers that are smaller than 1. So let's look at number 1. So we're going to move to the right until we reach the first whole number. So 1, 2. So we move 2 times. So since it's smaller than 1, it's going to have a negative exponent. And the remaining number is 2.59. Okay, let's look at number 4. So it's smaller than 1. So we know the exponent is going to be negative. So we're going to, let's see, boom. So we are behind the first whole number. So this is going to be, and we moved it only once. So that's 10 to the negative 1. So 3.15 times 10 to the negative 1. Let's look at number 8. So we want to get behind the first whole number. So there we are. So we're going to move 1. Bam. So our answer is going to be 2.058 times 10 to the negative 1. So we include, if there were, it, you just have to always get behind the first whole number when you're doing scientific notation. Oftentimes there'll be many, many zeros out here, but in these problems, they're not. Okay, so like this one, let's see, this one has more zeros. So we're gonna start at the last whole number. 1, 2, 3. So we moved 3 places. So the exponent is going to be negative 3. And we're going to write the remaining number, 1.45 times 10 to the negative 3. And number 14, we're going to move 1 space. So that's 10 to the negative 1. And the remaining number is 1.2. So our answer is 1.2 times 10 to the negative 1. So this is how you put numbers in scientific notation, and this is used mostly in science to find the sizes or to write the sizes of things that are very large, or distances that are very large, or distances that are very small, or things that are very small. Good luck.